So here we will be discussing application of derivative, the concept of maxima, minima and everything. You have already learned how to check whether the function given the point of maxima and to find the maximum value. Everything you have learned with the help of derivative, of course. So let's take few questions and let's solve it. Okay, just a moment. So one of the question we are having, which is if a rectangle is inscribed in an equilateral triangle of side length (2√2) as shown in the figure, then the square of largest area of such a rectangle is, okay, here figure is given like this. An equilateral triangle we are having, ABC. Okay, a rectangle is inscribed over here. So like this, a rectangle is inscribed. All right, here we are having, if a rectangle is inscribed in an equilateral triangle, the side of the equilateral triangle is given. So we know this is 2√2. We know this is 2√2. We know this side is also 2√2. Okay, this much information we are having in hand. And what we have to find, then the square of the largest area. So please don't get confused with this square word. We are talking about this rectangle only. Okay, we are talking about this rectangle. Let's say this is a rectangle PQ. Let me check whether the points are given over there or not. No. So we can take it as a PQRS. Okay. So this PQRS rectangle we are having, we have to find the largest area. Okay. The maximum area. And then the square of the largest area. So this square means area's power 2. It doesn't mean the shape is square. Here this shape is rectangle and square of the area. Once we will find what will be the maximum area, that area's square we will do. Okay, let's move ahead and let's see how can we find the area with the help of the given information. We are just having the side of this equilateral triangle 2√2, 2√2 and 2√2, nothing else. Okay, let's see what can be done over here. So if we can say that PQRS is a rectangle, let's say the length of the rectangle is X. Okay, and breadth of the rectangle or width of the rectangle, let's say, is H. This one is H and this one is X. Okay, so area will be, since it's a rectangle already mentioned in the question, so area will be length into breadth. Now area, that means we can represent it with A, that is equals to X into L. Now from here only, if we will start doing the derivative and everything, here you can see we are having two variable, one is X, another variable is H. So at least we must come at one variable. here we must be having either x or h, then only we will go ahead and we will do the derivative on both side area, and we will see what is the maximum area. We will find the critical point and then we'll find the maximum area. So x and h is there. So here this is h, and since it's an ABC is an equilateral triangle, so we know each interior angle of the equilateral triangle is of 60 degree. We already know, obviously, right? All the angle has to be same and it is of 60 degree. Now if we will take this part, that is, let me mark it PBS. Can you see over here PBS? Just a second. PBS, this one. Okay, so 60 degree we know, h we know, and what else? Is it possible to write this height in terms of sine theta or maybe cos theta? Is it possible? Yes or no? And what else we know? Wait. This total side is BC. Length of BC is 2 root 2. And we have assumed SR as a X. So the remaining part on the left and on the right, it will be 2 root 2 minus X. Yeah. The remaining part over here and over there, this 2 combined together will be 2 root 2 minus X. Yes or no? Yes or no?
Yes.
Now we know this part and that part. We have taken like equal. Here we have left equal space. There we have left equal space. So both are exactly equal. So if I am talking about the length of BS or maybe the length of RC, it will be 2 root 2 minus x by 2. Okay, half 2 root 2 minus x is this one and this one combined together. And if we will do the half of that, we will be having this part and that part also. Okay. We know BS. We know BS and we want to find H. We want to find H by using cos theta, sin theta, and by using this side BS. So which two side we want to use in this triangle PBS? Let me write it. In this triangle PBS, we want to use the side PS H and the side BS and also 60 degree. So you can see here we are having height and adjacent side, right? So tan theta can we use? Can we say tan 60? Tan 60 is equals to this height h over bs. Yes or no? Can we write it like this?
Yes, ma'am.
What is the value of tan 60?
Root 3.
It's root 3 h. Bs is this one. So rather than writing bs over here, I am writing it with root 3 into 2 root 2 minus x by 2. That is h. Okay, that is our height h. Now here we are going to use this height. This height we are going to use it over here. Then we will be having area in terms of one variable only, that is x, and then we can go ahead and we can do the derivative. We can find the critical point. We can go ahead, we can test whether the critical point is maxima, giving us maxima or minima, and accordingly we can find the maximum area. Okay, let's do that. So we will be having a area is equals to x multiplied with root 3 times 2 root 2 minus x by 2. Okay, this root 3 by 2, I am just keeping it aside for a while. So root 3 by 2, we will be having, if we will multiply x, we will be having 2 root 2 x minus x square. Okay, this x I have done the multiplication in the numerator and root 3 by 2 I have kept it aside. Is it clear so far? Is it clear? Now we will be doing the derivative on both sides with respect to x. Okay, so dA over dx will be root 3 by 2. Here 2 root 2, only 2 root 2, and here we'll be having 2x. Now for finding the critical point, what we do, we just compare it with 0 and then we get the critical point. So what will be the critical point over here? I can see 2 root 2 is equals to 2x. X is equals to only root 2. This is the critical point. Can you see it? Now what we do, we can go ahead and we can apply the second derivative test. Okay, so let's apply second derivative test, that is d2a dx2. If we will find, it will be root 3 by 2, and this is 0, this will be only minus 2. Okay, x, nothing will be there. So we can see the second derivative is already smaller than 0, and when it is smaller than 0, then it will be a point of, it gives us a point of maxima or minima. Yes, is it maxima or minima?
Maximum.
It's a maxima. So we can say this x equals to root 2 is a point of maxima. However, we didn't get the opportunity to just put the value, but still we got the point maxima. So whatever area we will be getting after using this value, that will be the maximum area. So we have to do the square of the area. Here it's written, then the square of the largest area. What will be the largest area? The largest area will be x into h. What is h? X into, what was h? It was root 3 times 2 root 2 minus x by 2. Root 3 times 2 root 2 minus x by 2. Okay, this is our h. X value we have already found, that is root 2. Let's put it over here. That will be the maximum area, root 3 by 2. 2 root 2 minus x value we have found as a root 2. So we are substituting it over here. Root 2 into root 3 by 2. Here we will be having 2 root 2 minus root 2 will be only 1 root 2 or only root 2. Okay. So it will just be root 2. Yeah. Now this root 2 and this
Row 3.
Can you hear me? Am I
Yes,
audible?
ma'am.
Yeah, really sorry. Just a moment. Let me share the screen. Can you see the screen? Can you see the screen? Please let me know.
Yes, ma'am.
So here we are having 2 root 2 minus root 2. So we'll be having only root 2. This root 2 will get multiplied together and will make 2. We will cancel it with this denominators too. Okay, if you are not getting, let me do. So we will be having like this one, 2 into root 3 by 2. This 2 and 2 will cancel out each other and we will be having only root 3. What we have to find here is square of the maximum area. This is the maximum area we are having. Okay, we have to find the square of the maximum area. That means square of this one. Okay, that means only 3. Is it clear? Here the word, if you will read the question, can be quite confusing, that if a rectangle is inscribed in an equilateral triangle of a side of length, this one as shown in the figure, then a square of a largest area of such a rectangle. So square means the power 2, not the figure is square. Here we are having a rectangle only. Okay, is it clear? Is it clear? Can we move ahead? Just
Yes,
a
ma'am.
moment.
Yes, ma'am.
Let me take another question. Okay, so the next question is, let A be a real number such that the function f of x is equals to ax square plus 6x minus 15, x belongs to R, is increasing in this interval and decreasing in this interval. Then the function, then the function gx is equals to ax square minus 6x plus 15, x belongs to R, has, then this function has, we have to check whether it has a local maximum at, it is maximum, okay, at x equals to minus 3 by 4, local minimum at x equals to minus 3 by 4, option C, local maximum at x equals to 3 by 4, or local minimum at x equals to 3 by 4, positive 3 by 4. Let's check. So here we are having, let A be a real number such that this is the function we are having. F of x is equals to ax square plus 6x minus 15, is increasing in this interval, decreasing in this interval. So then the function gx, we have to check whether it is increasing or decreasing and what is the interval. Let's take the function f of x. Even if we know in which interval it is increasing or decreasing, let's take this function f of x, which is given as ax square plus 6x minus 15. So f of x is given already as ax square plus 6x minus 15. Yeah. Now, since it is increasing in one of the interval, decreasing in other interval, how we check the function is increasing or decreasing? We find the first derivative, then we find the critical point, and then we take the interval according to the critical point, and accordingly we check it. So first we will do the derivative. F dash x, that is 2ax. It will be a is just a number, plus 6. This is f dash x. Now to get the critical point, we will compare it with 0, right? So it will give 2ax is equals to minus 6. X will be minus 6 by 2a. That means we got x value as a minus 3 by 4. Now in the question already it is written that the given function is increasing in this interval minus infinity to 3 by 4 and decreasing in 3 by 4 to infinity. So the given function already given. Okay, we are not writing this, making this real line and writing the interval and everything by ourselves. It is already mentioned in the question that here the function is increasing and here the function is decreasing. Okay. Now here we were having minus 3 by a. No, how we have written minus 3 by 4. Here we have got minus 3 by a. Okay. X value we have got in terms of a. When we will compare this x, this a, with this critical point, which is mentioned in the interval, if we will compare, then are you getting that a will be minus 4? Are you getting it? And accordingly, we have got the critical point for the given function. Yes or no?
Yes, ma'am.
Yes. Just by doing the comparison, where the interval is given over here for increasing and decreasing part, if we will compare with the given interval, in interval we are having 3 by 4, and if we will compare it with minus 3 by a, we can understand that a will be minus 4. Now to make it more clear, let's check it. For when a is minus 4, obviously our function, this function f dash x, when a will be minus 4, just for checking part. It is clear that a will be minus 4, but still if you are not sure, then we can take like this and we can see the function will increase in this interval and it will decrease in the other interval. Okay. So now the next part. Here it says, then the function gx, ax square minus 6x plus 15, this will be increasing or decreasing, or what will be the interval. So now the other function is given to us, that is gx is equals to ax square minus 6x plus 15. Ax square minus 6x plus 15. We have to find the point of local minima or local maxima. So what we'll do, g dash x we will find, that will be 2ax minus 6. Okay. A we already know. A we have already figured it out from the previous part, that a is negative 4. So it will be 2 into negative 4, that means negative 8x minus 6. Okay. Now let's find x value from here to get the critical point. So critical point we will be having, if we will compare it with 0, critical point will be 6 by negative 8. 2 3 times 6, 2 4 times 8. So minus 3 by 4 is the critical point over here for the other function gx. Okay. Now let's make the real line. Minus infinity, infinity, minus 3 by 4. We have to check whether the function is increasing or decreasing or what. So we will take the test point and we will check. Minus 3 by 4 is negative 0.7 something. Okay. So here we will be taking a test point. So what will be the test point? We can take test point as a 0. We can see g dash x, if we will put 0 over here as a x value, we will be getting a negative answer over here. Can you see? When we are taking 0, z dash x is greater than 0 or lesser than 0? Can you tell me? Tell me. Anyone?
Yes.
it is lesser than 0. Here z dash x is lesser than 0. This is the test point I have taken. This is the test point I am going to take. So minus 1 if we will take as a x value. So minus 8 into minus 1, it will be positive 8 minus 6. So positive 8 minus 6, it is plus. So z dash x will be positive over here. So here in this part, the function is increasing, and on the right part, the function is decreasing. Let's see the option: local maxima, local minima, local max, local minima. So when at first the function is increasing and then it is decreasing, that means the curve is like this. Okay, the curve is like this, and there is a point of maxima. We are getting the local maxima over here. Minus 3 by 4, this is the point of maxima. Okay, so local max at minus 3 by 4. Option A is the correct option. Is it clear? Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Let's move ahead. If you will read this question in one go, you will think that this one and this one is exactly same. However, there is a variation in sign, and these two are different function. We have to take one at a time, and then we have to see what is the value we are getting for A, and then we will check. Let's take the next question. Okay. The next question we are having is the triangle of maximum area that can be inscribed in a given circle of radius r is option A, an isosceles triangle with base is equals to 2r, an equilateral triangle just a second. An equilateral triangle having each of its side of length root 3r. Wait, no. Next one is an equilateral triangle of height 2r by 3, and option D, a right triangle having two of its side of length 2R and R. Okay, these are the options we are having. So let's see what the question says. A triangle of maximum area that can be inscribed in a given circle of radius R. We are having a circle. We are having a circle. We know the radius of this circle is R. Okay. We have to make the triangle that can inscribe the maximum area. So if we will be having this triangle, let's say ABC is the triangle. Okay. Now area we have to maximize over here. For the given triangle, area we will be maximizing. We don't know which type of triangle we are having. Isosceles triangle, equilateral triangle, right angle triangle, which type of triangle it is, we don't know. Okay. No other information is given over here apart from the radius R. Okay. So we know the radius is R and ABC is a triangle. So when we don't know which type of triangle we are having, we can say the area of the triangle formula says that the area will be 1 by 2 into base into height. Base into height. Okay. So here, what will be the height? So we have to drop a height over here. Let's drop a height. This is the center O. So let's, AP is the height and base is BC into half. We have to maximize this area. But AP we don't know. BC we don't know. What we will do over here? First, let's make one expression so that we can go ahead, we can do the derivative and then we can find the critical point and we can maximize the area. So, first BC. This BC, since we have dropped the perpendicular, this perpendicular will divide this side in two equal part. Okay, this BP and PC will become same. Okay, so what we can say that we know that BC is equals to 2BP. And one more thing we can consider here. Let's see, we are doing one construction over here. Just a second. So we know BC is equals to 2BP and we can do one construction over here. We can just make an angle like this and let's take this one as a theta. Okay. So we will be having BC. At the place of BC, we can write 2BP. AP, just a second. So we can use this twice of BP over here. At the place of AP, we can break it in the form of AO plus OP. And this 1 by 2, we need to just write it as it is. Okay. Now after this, what can be done over here? BP. This BP we are having and this one we have assumed as a theta. We can say this is R. Okay. This is just the radius of the circle. Now I want to use this radius and I want to use this theta also and BP also. BP, OB and theta. in this triangle OBP, we know theta is there, our radius is there. I want to write a trigonometric ratio over here by using the side BP and the side OB. So adjacent side is there, BP is adjacent side, and OB is the hypotenuse. That means cos theta we can use, right? Cos theta is equals to BP over OB. Can we write it like this? Can we say that BP
Yes,
will
yes,
be OB is R cos theta? Yes or no? Can we write it like this?
yes,
This
ma'am.
2 and 2 we can cancel over here, and BP we can write R cos theta. Let me know whether this one is clear or not. Now AO plus OP. AO is nothing but again the radius only. So AO is the radius. We know AO is R. And what about OP? This OP, again we will be using the radius, this triangle, and this side. So this side is the perpendicular. We can use sine theta. So we can say OP will be OP over hypotenuse. So OP will be R sine theta. Can I say? Let me know. Are you getting? Are you getting it?
Yes,
Let's move ahead. Let's move ahead. So we will be having, let's just keep it like this, or we can also break it. We can take R common from here. So it will become R square cos theta, and here we'll be having 1 plus sine theta. Now everything is in terms of theta over here. We just need one variable, beta x, beta y, beta z, beta theta. Okay, so area we have written, and on the other side everything is theta. R is the radius, but that is constant. Okay, so we will treat R as a constant over here. We will find dA over d theta is equals to R square. Now here product rule we will apply. Okay, so first function, derivative of second function, that will be again cos theta, plus second function, derivative of first function will be minus sine theta. That's it. Okay, let's just expand it, do the multiplication. We'll be having cos square theta over here. We will be having minus sine theta over here. Here we will be having minus sine square theta. Okay. Now, if we will write this cos square theta as a 1 minus sine square theta, let's see what are we going to get. 1 minus sine square theta for this one, minus sine theta, minus again sine square theta. So what we are getting here? R square. This minus sine square theta minus sine square theta is becoming minus 2 sine square theta. So we are getting minus 2 sine square theta minus sine theta plus 1. Okay. Now we will, this is our dA over d theta. We will factorize it and then we will compare it with 0 to get the critical point. Okay. So if we will factorize this, let's say this sine theta is just t. So we are having minus 2t square minus only t plus 1. This is what we are having. So we can, if we will factorize, it will be 2, 1 times 2. So we can write it as a 2t and t. Here we will write minus 2t plus t plus 1. This is how we can split the middle term. We need to take out common. So common will be minus 2t. Here we'll be having t plus 1. Here we'll be having plus 1, t plus 1. So we got t plus 1 and we got minus 2t plus 1. Okay. So we got t is sine theta. So we got sine theta plus 1. And we also got 1 minus 2 sine theta, or minus 2 sine theta plus 1. Outside r square is there. Are you getting this step? Yes or no? Are you getting it?
Yes, ma'am.
Okay, let's move ahead. This is our dA over d theta. Still we have not found the critical point. We will compare it with 0. If we will compare it with 0, then sine theta, either this one will be 0 or that one will be 0. Okay, if since this one is 0, this implies that sine theta is equals to -1, and the first, like we can, here theta will be 3 pi by 2. Okay, so when theta is 3 pi by 2, that means when we will take pi plus pi by 2, then we will get the sine theta value as a -1. Alright, that means 3 pi by 2. Here we are getting sine theta is equals to 1 by 2. That means theta is 1 by 2 means pi by 6. Yeah, pi by 6. Here we are getting 3 pi by 2. There we are getting pi by 6. What is theta? Theta is just an angle inside the triangle. So 3 pi by 2 means what? 3 pi by 2 means 270 degree. And we know inside a triangle, the sum of all interior angle is 180 degree. So if we are saying this is 270 degree, this is completely incorrect. Okay, it is not at all possible. It can't be 270 degree. We need to take the other value of sine, we need to take the other value of theta only, that is pi by 6. Okay, that means 30 degree. It can be 30 degree, but it can't be 270 degree because we are talking about the interior angle inside a triangle. Okay, interior angle of a triangle, I mean. So pi by 6 we need to take to proceed. This one we will not be taking. So theta is equals to pi by 6 we got as a critical point. Now we need to check. This is negative infinity, positive infinity, pi by 6. What we need to check? The triangle of maximum area. Okay, the area we have to check is maximum at which point. What is our area? The area we have written this one, r square cos theta in bracket 1 plus sine theta. Okay, before that we need to check whether this point is a point of maxima or not. So double derivative test. Yeah, we can apply double derivative test. Let me rub this part, and here only we will be applying the double derivative. So d2a, d theta 2 will be r square. Let's keep it as it is. First function, derivative of second function, minus 2 sine theta is there. It will become minus 2 cos theta. Plus second function, derivative of first function, only cos theta. If we will expand it, it will become r square. Here we'll be having minus 2 sine theta cos theta minus 2 cos theta only plus cos theta minus 2 sine theta cos theta. Yes, this is what we are getting over here. Now it will become r square. This minus 2 cos theta plus cos theta will become only cos theta, and minus 2 sine theta cos theta minus 2 sine theta cos theta will become minus 4 sine theta cos theta. Okay, here we can take out cos theta common out. So we can say it will be cos theta out and 1 minus 4 sine theta. This is what we are getting as a double derivative. We know the theta value is pi by 6. We need to put here to just check whether it will be positive or negative. So theta pi by 6 r square. Here if we will take cos pi by 6, it will be root 3 by 2, right? And sine pi by 6, that means 1 by 2. So we can see it is negative. Can you see? It is less than 0. 1 minus 2 we are getting inside the bracket. So obviously it is less than 0. Okay. So pi by 6 is the point of maxima. the maximum area will be r square cos theta 1 plus sin theta. This was the area. So pi by 6 we will take over here. 1 plus sine pi by 6. So r square cos pi by 6 is root 3 by 2 and 1 plus 1 by 2. That means 3 by 2 from here, root 3 by 2 from here into r square. This is the maximum area we have got. Options are an isosceles triangle, equilateral triangle. Okay. Okay. So area it's not given in the option. We have to check whether the triangle we are having, that is isosceles triangle, equilateral triangle, or what. Okay. So what we can do, we have already found this side. This side AP we have found and BC we have found. When we were writing the expression for the base and height, then AP, BC, everything we have found in terms of cos theta and sin theta. So BP, you can see it is R cos theta. BP was R cos theta. And BC was the total base BC of the triangle was 2 times BP. So we can take 2R cos theta. Cos theta means theta is pi by 6. So it will be 2R into root 3 by 2. This is our B side BC. This con we are having side BC as a root 3R. Okay. What about the other side? Other side still we are not able to find, but this AP we know. What is AP? AP is R plus R sin theta. Okay, AP is R plus R sin theta. If we will take sin R common, so it will be 1 plus sin theta. Sin theta is 1 by 2 pi by 6. So that means 3R by 2. Height we have got 3R by 2. Base we have got as root 3R. Are we doing any mistake? No. Now height we know. Is it possible to find the side AB? Is it possible? Yes or no? Yeah, it's possible. The area which we have found, no, that area we can use, and then we can say area is equals to 1 by 2 into height, this height, and this weight. It's an isosceles triangle with base 2R. No. It's an equilateral triangle with each side root 3R. Side we have got root 3R. One of the side we have got root 3R. Next option. Equilateral triangle of this, we know. Height 2R by 3 we have got. Is it so? No, 3R by 2 we have got. So option C is also, this is incorrect. This is incorrect. A right angle triangle having two of its side, no, this is incorrect. So we can say without even solving the other, like proceeding ahead, we can say that this option is the correct option. Yes or no? Are you getting it? Are you getting?
Yes, ma'am.
Okay, so no need to go ahead. Here only we can declare that other option are incorrect. So this is the correct option we are having. Let's move ahead. if we are having a piecewise function like this, let f such that R to R be defined as, if we are having a piecewise function where f of x is equals to minus 4 by 3 x cube plus 2x square plus 3x when x is greater than 0 only, and 3x e to the power x when x is smaller than or equals to 0, then f is increasing function in the interval. F is increasing in which interval? The intervals are given over here. Is it minus 1 by 2 to 2? Is it 0 to 2? Is it minus 1 to 3 by 2? Or it is minus 3 to minus 1? Okay. So let's see how, when we are having this type of piecewise function, how we will check whether the function is increasing or decreasing, and which is the, like, what is the interval where the function is increasing. So first, what we do to check increasing or decreasing? Increasing means what? F dash x greater than 0. Decreasing means what? F dash x is smaller than 0. So first we need to find f dash x, obviously. Let's find it for the given function. So f dash x we will be finding. It was a piecewise function. Carefully we will find the derivative and we will be writing it over here. So minus 4 by 3 x cube is there. X cube will be 3x square. Minus 4 by 3, 3x square. We are doing the derivative here. Plus 2x square is there. That means plus 4x we will be having. Plus 4x we will be having. Plus, what was there? 3x is there, so only 3 will be remaining. X greater than 0. We need to write the condition here. X greater than 0. 3x e to the power x we are having as the other function. 3x e to the power x. That means product rule we need to apply. First function derivative of second function plus second function derivative of x will be 1. When x is smaller than or equals to 0. So we have done the derivative of the given piecewise function. Now what we will do? We will check the interval where the function is increasing or decreasing. This cancel out, but before that let's do the factorization so that we can find the critical point. So f dash x will be, we are having there minus 4x square plus 4x plus 3. Minus 4x square plus 4x plus 3. If we will try to split the middle term, as it is quadratic expression, 4 3 times 12, 6 2 times 12. So we can write it as minus 4x square plus 6x minus 2x plus 3. X greater than 0. Here we will be having, here we can take out e to the power x common. So we'll be having x plus 1. X is smaller than or equals to 0. F dash x will be, if we will take minus 2x common, so we will be having 2x minus 3. And if we will take minus 1 common, so minus 2x minus 1. Here we are having 3 to the power x, x plus 1. Why we are doing it? So that we can get the critical point for the first condition, for the second condition directly from here. We don't need to write all the steps, but we need to understand what will be the critical point. Okay. So directly we can understand from here. Here minus we can take out common. Okay. If we will take out minus common here, this will become plus and this will become plus. Okay. Now critical point for the first condition, I am taking two conditions over here. Okay, one we will be doing the x greater than 0. This one we will be doing on the left hand side and x is smaller than or equals to 0, we will be doing on the other side. Now, real line, minus infinity, plus infinity. Critical points are 3 by 2 and minus 1 by 2. Critical points are 3 by 2 and minus 1 by 2. Okay, now let's check whether in which interval the function is increasing and where the function is decreasing. How? By taking the test point quickly. So 3 by 2 means 1.5. That means we can take the test point here as a 2. Okay, if we will take the test point 2, let's see this expression 2 into 2, 4, 4 minus 3. It is positive. Other one, 2 into 2, 4 plus 1 positive. So it will be negative. Can I say f dash x is lesser than 0 over here? Can I say? Can I? Yes or no?
Yes, ma'am.
In the next interval. Minus 1 by 2 to 3 by 2. 0 we can take as a test point. So 0 if we will take negative. 0 if we will take positive. Negative has become positive already. This is positive. So we can say that f dash x is greater than 0 here in this interval. And in the other interval, if we will take test point as, let's say if we are taking test point as a negative 1, can we? Yeah, we can, because this is minus 0.5. So here if we will move negative 1, we can take as a test point. So negative 1 if we will take 2 into negative 1 minus 2 minus 3, negative answer it will give. And if we will take negative 1 as a test point, so minus 2 plus 1, this is also negative. Okay, so 3 negative, that means negative. F dash x is negative. What we want? We want where the function is increasing, in which interval the function is increasing. So here we have got in between minus 1 by 2 to 3 by 2, the function is increasing. Okay, but we need to take in consideration one thing, that x is greater than 0. When x is greater than 0, then only this is defined. X greater than 0 is the domain. The function is not defined when x is smaller than 0. We can use this expression, the first expression, we can use it when x is greater than 0. Okay, so x has to be greater than 0. This, if this point is 0, it has to be greater than 0. This is the first and foremost condition which we have to keep in mind when we are using the first expression. Okay, so we have defined that f dash x was greater than 0 in the interval minus 1 by 2 to 3 by 2. But now after writing this, we realize that this is defined when x is greater than 0. Okay, then let's take 0 to 3 by 2 as our interval rather than this one. Are you getting me? Are you getting it?
Yes, ma'am.
Yes. So this is the interval we have got from here. F dash x greater than 0 in this range. Okay. And x is greater than 0 means this is the range. Now common one we will be taking. Okay. So from here we are getting 0 to 3 by 2 as an interval. Next one we will be doing the same thing. We are having 3 e to the power x plus 1. Okay, so x plus 1 is there. From here we are able to get the critical point as a minus 1. E to the power x, we can't say anything about that. Okay, whatever be the value of x, it will be positive only. So critical point we are getting from here, one and only one critical point, that is negative 1 we are getting. Here negative infinity, here positive infinity. We need to check in which interval the function is increasing, in which interval the function is decreasing. So if we will take here any test point, let's say 0. If we will take 0, e to the power 0 positive, 0 plus 1 positive. So f dash x is positive over here. If we will take any test point over here, let's say -2. So e to the power -2, a positive number, -2 plus 1, a negative number. So f dash x is smaller than 0. So in which interval the f dash x is greater than 0? In this interval, -1 to infinity. Okay, open interval. But we must keep in consideration the condition which is given at first in the question, that is x is smaller than equals to 0, then only we can use this expression. So x is smaller than, let mark 0 over here. So 0 may be, this is the point 0, and x is smaller than or equals to 0. X is smaller than or equals to 0. That means this point. Okay. So from here, what are we getting? We are getting that we can take here only the function is increasing. Okay, this is the common reason which we can take over here. That means -1 to 0. Okay. Now when we are having piecewise function, we will be taking the union of overall. What is the interval where the function is increasing? So overall this reason plus this reason where the function is increasing. Okay, so union we will be taking, not the intersection. Okay, overall these are the reason where our function is increasing. Okay, so let's mark it. We are having real line -infinity, infinity, 0 is there, 3/2 is there, -1 is there. So 0 to 3/2, 0 to 3/2. This is one of the interval we have got from the first one, and from the previous one we have got -1 to 0. From the previous one we have got -1 to 0. Okay, open interval. So overall, can you see -1 to 3/2? Overall, can we write -1 to 3/2? This is the interval, the union of both the interval where the function is increasing. Yes or no? Let's check. Option C. Are you getting it?
Yes, sir.
This is how we will deal with piecewise function. If this is not clear, let me take one more question from here only. Definitely you will be able to understand. Suppose our question is, let f such that R to R defined as f of x is equals to -55x if x less than -5, 2x cube minus 3x square minus 120x if x is greater or equals to -5, less or equals to 4, 2x cube minus 3x square minus 36x minus 336 if x is larger than 4. Here also, then let A is equals to set of all x such that x belongs to R and f is increasing. Okay, then A is equal to, options are -infinity to -5 union 4 to infinity. Option B, -5 to infinity. Option C, -infinity to -5 union -4 to infinity. Option D, -5 to -4 union 4 to infinity. These are the options we are having, and this is the piecewise function we are having. Okay, we have to check where exactly the function is increasing. Let's check it. The way we have done the previous one, we will be doing it quickly like that only. First thing first, we will be finding f dash x. Let's find it. So f dash x. First one is minus 55x. It will just be minus 55. We need to write the condition here. If x is less than minus 5. If x is less than minus 5. Next one. Here 2x cube minus 3x square minus 120x. So if we will do the derivative, it will become 6x square minus 6x minus 120 if 6x square minus 6x minus 120 if x is lying in between minus 5 to 4. Next one, 2x cube. Okay, when we will do the derivative, it will become 6x square minus 6x again minus 36. That's it. Yeah, 336 is a constant. So if x is greater than 4, if x is greater than 4, this is the derivative we are having. We will try to just factorize the second one and third one, and then we will be repeating the same process. Let's do the factorization quickly. So the second one, if we will do 6, we can take out common. It will become x square minus x minus 20. 5 4 times 20. Okay. So 6, we can break it as a minus 5 plus 4. Okay. So x square minus x minus 20, we can break it as a minus 5 plus 4 x square, and here minus 20. X we will take common, it will be x minus 5, and here plus 4 we will take common. So x plus 4. Okay, this is what we are getting. 6x minus 5, x plus 4. Please do it with me so that we will not do any mistake while doing the factorization or simplification. Other one is 6x square minus 6x minus 36. Here also we can take out 6 common. We will be having 6x square minus x minus 6. 6 means 3 2 times 6. Again we can take minus 3 plus 2. So we will be having x minus 3, x plus 2. Is it okay? Is it okay so far? Is it clear?
Yes, ma'am.
Okay, let me write it in a box so that we will not get confused that what we have done. Okay, these are the functions, derivative and the form we are having. Now here we are having 3 parts, so we will be segregating it in 3 parts. But the first condition, here we are having f dash x greater than 0, we need to check. Whatever with the value of x here, f dash x is smaller than 0, right? So this one we will not take in consideration because we are searching for set of all x where f is increasing, set of all the elements, set of all the values where x is increasing. So x is decreasing in this interval. Okay, we will not be taking that. Next, the next two we will be taking over here. So 2 part we will be doing here. For the first one, the condition I am writing here, x is lying in between minus 5 to 4, and the factorization, according to the factorization, I am just marking down the critical point, that is 5 and minus 4. Critical point over here, minus infinity, infinity, 5 and minus 4. Okay, we need to check where exactly the function is increasing, where the function is decreasing. So we are having here 6x minus 5, x plus 4. We were having here 6x minus 5, x plus 4 as a f dash x. Okay, if we will take a point, a number which is bigger than 5, that is 6. 6 minus 5 positive, 6 plus 4 positive. So this is positive. F dash x greater than 0 we are getting here. Okay, let's take quickly a test point in between minus 4 to 5, 0. The first bracket is giving negative value, second bracket is giving positive value. Eventually we are getting a negative, that means f dash x is smaller than 0. Are you getting it? Now in between minus infinity to minus 4, if we will take minus 5, so minus 5, negative answer, minus 5 plus 4, negative, 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 positive. So we got f dash x greater than 0. Okay, so the interval we got, this, the extreme left and the extreme right, these are the two intervals where our function is increasing. But we must not forget where the function is defined, the range where the function is defined, the domain of the given function, that we must not forget. So the function is defined. Okay, this one is the interval we want to take, and this one is the interval we want to take for f dash x greater than 0. But the function is defined in between minus 5 to 4. Minus 5, close interval, to positive 4. Okay, here positive 4. We need to take the common part of the sky one and the yellow one, that's it. Okay, so we will be taking here only this part, only this part. Can you see? So we will be taking minus 5, wait, here it is 4, minus 4 to infinity, and here minus 5. So minus 5 to minus 4 we can take, right? Yes or no?
Yes, ma'am.
Let's do the same thing for the next part. We are having x minus 3, x plus 2, minus infinity, plus infinity, test point 3, test point negative 2. Let's check the function is increasing, decreasing, where exactly 16 we have. So if we will take more than 3, 4, positive, positive, greater than 0. If we will take in between minus 2 to 3, 0, negative, positive, negative, less than 0. If we will take here, maybe minus 3, negative, 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 positive, f dash x greater than 0. Okay, so we wanna take this part, and we wanna take this part. Okay, but here we are having x greater than 4. Okay, the predefined, the domain is given over here, that is x greater than 4. So here we must be having 4 and x is greater than 4, like this. Okay, so instead of 3 to infinity, we can take 4 to infinity. Okay, and now we need to take the union of this one and this one. Here I can see the option, in the option portion, unions are given over here. So we are having minus 5 to minus 4, then 4 to infinity. Minus 5 to minus 4, 4 to infinity. So this option is the correct option. Can you see? Can you see it? This is how we will be solving these questions when we are having piecewise function. Let me take another question. In this chapter, you will find most of the question which easily you will be able to do without knowing any extra concept or anything. Everything is already known to you. Okay, so most of the question from here, from the previous year question paper, you will be able to do. Here it says the maximum slope of the curve y is equals to 1 by 2 x to the power 4 minus 5x cube plus 18x square minus 19x occurs at points are 2, 2, B 0, 0, C 2, 9, and D 3, 21/2. So the maximum slope of the given function occurs at. Here we just have to find the point where the function is maximum, right? But one thing is here which we need to be clear, that is maximum slope. Slope means dy dx. Okay, slope means the first derivative we do to get the slope, right? Dy dx. This is the slope. Okay, so first we will be finding dy by dx, that is 1/2 x to the power 4 is there. It will be 1/2 4x cube minus 15x square plus 36x minus 19. So this one is the slope. In the previous question, what we did, the first two question, area we had to maximize. So first we have written the expression for the area and then we started doing the derivative. So this is the slope we are having. Now we will start from the very beginning every process for maximum to check where this slope is maximum. So we can say this, let's say this is gx. Gx is 2x cube minus 15x square plus 36x minus 19. This is gx and we have to maximize this gx. We have to maximize this slope. The process which we follow, same process we will be following over here. G dash x we will be finding first, then we will be finding the critical point, then we will see what is the point of maxima either by the first derivative test or by the second derivative test, right? Let's do that. So if you are getting confused that why we are doing 2 times derivative, now one time we have done, another time we are going to do, this is the slope we have found. Okay, the slope we are going to maximize now. So we will be having 6x square over here minus 30x plus 36. Let's find the critical point. So critical point will be z dash x is equals to 0. That will give 6x square minus 30x plus 36 is equals to 0. 6 we will take common. We'll be having x square. 6 5 times 30. Yeah, this is what we'll be having. 3 and 2 will be having minus 3 minus 2. So first we will be having x minus 3 and another one will be x minus 2 or what? Yeah, x minus 2 is equals to 0. So the critical points are 3 and 2. X is 3 and 2. These two are the critical point. Now we can apply the second derivative test, as it is very simple to do the derivative again. So g double dash x we will be finding. That will be 6 2 times 12x minus 30. Now g double dash x at x equals to 3 and g double dash x at x equals to 2 we will be checking. When x is 3, 12 3 times 36 it is positive, and when x is 2, 12 2 times 24 minus it is negative. When it is positive, this is the point of minima. Okay, when it is negative, this is the point of maxima. So x equals to 2 is the point of maxima. Okay, x equals to 2 is the point of maxima. What we have to find here? The maximum slope of the curve occurs at. Okay, so coordinate we have to find. X equals to 2 we have found. So maybe A or C is the correct option. So maximum we have to find. So y value we also have to find here. In the original curve, this here we will be substituting x as a 2 and we will check what is the y value. So if we will substitute x as a 2 over here, we will see what is the maximum value. 1 by 2, 2 to the power 4 minus 5 into 2 cube plus 18 into 2 square minus 19 into 2. So we will be having 2 cube over here only, that is 8. We will be having 8 5 times 40. 4, 18 4 times 72. Yeah. And 19 2 times 38. Let's do the calculation and let me know what are you getting. Please do the calculation and let me know. Yes? Anyone? What are you getting? Let's check. So 8 here, 40 and 38.
2.
Okay. You are getting 2. That means option A is the correct option. Everyone getting 2 only, right?
Yes, ma'am.
Yes, this is how we will be checking whether the slope is maximum or not. Let me check any other concept which we can discuss here. Okay, one of the question is, I'm not writing the question, just writing the function. A function f of t is given as at square plus bt plus c. Okay, where a, b, c are real number and the position of a moving car at a time t, it is represented by this function. It is representing the position of a moving car. We have to find then the average speed of the car over the time t1 t2. Average speed over this time interval we have to find. Average speed we have to find. Here the condition few options are given over here, t1 minus t2 by 2. Like if the average speed we have to find, then the average speed will be attained at which time, that we have to find over here. So for this question, average speed means we are having two ways of finding the average speed. One of the ways, this is the position of the car at a certain time. If we will do the derivative of it with respect to time, okay, ft, if we will do the derivative of this function with respect to rate of change of the given function with respect to time, that will be the speed, right? So f dash t, if we will find, that will give us the speed. Okay, because when we are finding the derivative, that is only the rate of change with respect to time. So it will be 280 plus b. And one more way is there, which we have learned in the previous class, that speed is equals to distance over time. So here over the time interval t1 and t2, so we can take this position, we can do ft2 final minus initial over the time period t2 minus t1. This is how we can find the average speed. So one of the way is the left hand side way of finding the average speed. Another side is also giving us the average speed. That one we are doing with the by using the concept of derivative. So from here, whatever we will get, no, we will be getting a t2 square plus b t2 plus c minus a t1 square minus b t1 minus c over t2 minus t1. Okay, this c and c gone, and if a we will take common from here and here, you can see we will be having t1 plus t2 in one bracket and t1 minus t2 in another bracket, because it looks like a square minus b square. Okay, if we will take b common, we will be having t2 minus t1. Denominator T2 minus T1 is there. So eventually we will get from here T2 minus T1, we will take common from the numerator and it will get cancelled out. We will be having a T1 plus T2 plus B. That is equals to, this is also a speed, and on the other side also we have found the speed only, that is 2AT plus B. Now from here we can take out the time. That time is given in the option. Okay. So we need to take out time from here just by doing the comparison, and we will get the answer from here. Are you getting it? The function was representing the position of a car. Average speed we needed to find, and it is written over here. Then average speed of the car over the interval T1 to T2 is attained at the point or attained at a time. Okay. Are you getting?
Yes, ma'am.
So this is how we will be finding the average speed. Few questions I give for practicing. Is there any doubt whatever we have discussed so far?